to view the slides in a full screen mode?
Ma'am, we are able to see slides, but not in full screen mode.
Okay. Now?
Yes, ma'am. Now it is full screen.
Okay. Good evening, dear participants. So I'll be going through the introduction to natural language processing since from 2 days you are being introduced to deep learning techniques. You were being introduced to generative AI, and in the today's morning session you have got introduced to the text analytics. So this is very important for us to understand the basics of the natural language processing. So I would be going through the part of natural language processing, make you people understand what is a natural language processing is, why it is very important, why the people are why the most of the research is being done in natural language processing, and so on. Once it is been done, I'll make you people understand what are language models and what are the different language models are. So some of the models you might have seen in the first lecture today, so I'll be going through those lectures also. Okay, I'll just recap them in some of the models because some of the models were been covered in the first half. Then we'll try to understand how actually the language models are being built. Okay, so this is the overall view of this lecture. So let me start with natural language processing. So natural language processing is one of the most important and the latest topics of artificial intelligence. Okay, let me check my slides. Hmm. So, can you tell me how do you define a language? So, how can we define a language? Yes. How do we define a language? Any one of you? See, the workshop, it is an online mode. So, it would be very good if the student or the participants would interact with the speaker. So, how do we define a language? Or what you mean by a language? Yes, you people there?
And it's a medium to communicate with each other.
Yes, it's a medium to communicate with each other, right? So you can call it as it is a tool which is used to express our thoughts and ideas, right? So how do you go with building your language? So language would be a vocabulary which consists of set of words. Then a text is composed out of these vocabularies. Then you can see a language is been constructed as set of all possible text. So natural language processing is mainly of two words which we have to understand. One is natural language and other one is processing. So let us start with understanding what is a natural language is. So when we talk about natural language, so language is, as I said, is one of the most important uh, thing or the medium for the communication between the humans, which they naturally do. So it's like transferring the knowledge from one brain to other at at an instantly, right? So language comes in many shapes and sizes. They can be spoken or written and are made up of different components, like you can see sentences, words, characters, and so on. So natural language processing is being developed naturally in humans. So you can see any of these languages like English, Hindi, Telugu, French, or any of the numerous languages which has been developed naturally in humans. So natural language processing is being developed naturally in humans. which you can see, a language which is one side it is being written in English, which has been converted into an Hindi language. So well, we know that human beings are the most advanced species on the earth, and there is no doubt about it. So, our success as a human being, because of our ability to communicate and share information, now that's where the concept of developing a language comes in. And when we talk about the human language, it is very diverse. So, it is one of the most diverse and complex part of considering. So you can see there are around 65,000 languages that exist. So the difference between a natural language and non-language, so the programming language which comes under non-language. So if you look into the difference between the natural language and the computer language, natural languages have a very large vocabulary, but when you consider the computer language, they have very limited vocabularies. Now, when you look into the natural language, they are easily understood by the humans, but when it comes to computer language, they are easily understood by the machines. Next one is natural language is very ambiguous in nature. Computer language is unambiguous. So this is where the actual talk comes into, that is the language is very ambiguous. So this is what actually gets us into this natural language processing. So we'll try to understand what you mean by ambiguities in the natural language. Okay, so in order to produce significant and actionable insights from the data, it is very important for us to get acquainted with the techniques of the text analysis and the natural language processing. Why? Because we are in the 21st century, so the data is being generated as we speak, tweet, send messages on the WhatsApp, or it could be on the various social media platforms. So a lot of data is being generated in the textual form and which is highly unstructured in nature. So what do you mean by highly unstructured in nature? Because as you write, let's suppose if you are writing a tweet or you are writing something else on the social media. So nowadays you would be using the short forms. There would be a lot of emojis. And when you go with using the hashtags, at the rates, and the emojis, and so on. So before getting into NLP and this, so let us try to, because most of the times the students get confused, that text mining and natural language processing. So I'll give a small glimpse of what is a text mining and natural language processing. So text mining, so it is text mining usually involves the process of structuring the input text, deriving the patterns within the structured data, and finally evaluating and interpreting the output. So it is nothing but the process of deriving a meaningful information from the natural text. So text mining is also known as text data mining. When you look into the natural language processing, so it refers to the artificial intelligence method of communicating with an intelligent system. So a text mining refers to process of deriving high quality information from the text. When you look into the natural language, it deals with the intelligent system using the natural language. So the overall goal, if you see, is essentially to turn the text into a data analysis via the applications of natural language processing. That's the reason this text mining and natural language processing go hand in hand. So, since you can see we are humans, we are able to understand the language, what is been written here, that is hello, how are you, kya hal hai, and so on. But what about the machine? What if these languages are being fed to the machine? Will it be able to understand them? No. So, in order to make it understand, this is where the natural language processing comes into. So NLP is the ability of a computer program to make it understand the human language as it is spoken. So how actually they are being converted? So we use this natural language which are being further by using NLP techniques. They are being sent and processed. So in order to get the useful text. So before getting into this, so we need to understand some of the linguistics and languages. So linguistics is the science of language. Its study includes, like, if you are studying with respect to sounds, we refer to them as phonologies. If you are working with word formation, then we refer them as morphologies. If you are working with the sentence structures, then we refer them as syntax. If you are looking into the meanings, we refer to them as semantics. Next, understanding refers to pragmatics. So let us get into the actual definition of the natural language processing. So natural language processing, or we can call it as NLP, also known as computational linguistics. So it is a blend of machine learning and artificial intelligence. So now you can see, let's suppose a few years ago, we used to type keywords into the Google search in order to get some effective results. But today you have the comfort of vocally speaking. You help with the technology like assistant. Instead of typing, you just click the Google Assistant and just speak out what is the search we want to do. So these are some of the virtual assistants which came into existence only because of natural language processing. If you look into some of the examples, so that is one of the one is Google Assistant. Just say okay Google on your Android phone and you can open anything on your phone. Then you have Siri on your iPhones, then Cortanas, you can see Alexa and so on. So how the Alexa is able to understand the human language. So you say Alexa, play the music. So how it is able to understand? So the human language, the natural language is being converted in the form of text, which is being analyzed by an Alexa, and further the reply is being converted in the form of text and generated in the form of sound. So these are the products of natural language processing. If you look into some another example with respect to Siri, so if I want to say hello Siri, what is the distance between Earth and the Sun? It immediately replies that the distance between Earth and Sun is 149.6 million kilometers. Okay, so one more example, if you see, I am hungry in Hindi, so it will definitely convert it into the Hindi, that is, मैं भूखा हूँ. Like if I say I am hungry in Telugu, so it will say నాకు ఆకలిగా ఉంది. So all these virtual assistants, either it may be Siri or the Google Assistant or Alexa or any of the virtual assistants, all are these possible because of natural language processing. If you look into the why there is a need and the goal of the natural language processing, so there are two needs. One is what we call it as engineering goal, that is to develop an automated tools for language processing. The other one is the science goal, that is to gain a better understanding of the human communication. So these are there are two different components of natural language processing. So these are very important components of natural language processing. One is what we call it as natural language understanding. The other one is what we call it as natural language generation. So natural language understanding. So it deals with understanding the inputs which are being given by user as a part of natural language. So here the input could be either in the form of text or speech, right? So generally it refers to mapping the given input into a language, into an into a natural language, into useful representation and the aspects of the language. So this is where the machine analyzes the different aspects of the language. So you can see this is a language which is being fed to the machine and it try to analyze the language. So natural language understanding involves the following tasks. First one is mapping the given input into an useful representation. Second one is analyzing different aspects of the language. So NLUs are mainly used in business applications in order to understand the customer's problems in both spoken as well as in the written language. But when you are talking about natural language understanding, so there are certain ambiguities because, as I said, a language is ambiguous. So we let us look into some of the ambiguities in the language because NLP is difficult only because of these ambiguities. So now you can see first one is the lexical ambiguity, second one is the syntactic ambiguity, and the third one is the referential ambiguity. In the syntactic lexical ambiguity, so understanding in this already. So taking our English, let us consider English. I'm going to consider all the example with respect to English language. So there are a lot of ambiguities which can be seen. So let's see, the first one is the lexical ambiguity. Lexical means a word, or you can say the word level. So lexical works at the word level. So lexical ambiguity exists in presence of two or more possible meanings of a sentence within a single word, or you can say the possible meanings within a single word. Now if you look into these two examples, she is looking for a match. The fisherman went to bank. So these are the two sentences where you can see the word match could have more than one meaning. She is looking for a match. So I could interpret two different meanings out of this match, that she is looking for a partner to get married, or she is looking for a cricket match. So these are the two different interpretations which I can come up with the match. Next one is fisherman went to the bank. So you may say, since there is a word like fisherman, so definitely he might have gone to the river bank. But there could be two different interpretations which I can get for this bank. That is, one could be the river bank, the other one could be the money bank. So the fisherman might have gone to the bank to deposit the money, or the fisherman went to the bank to catch the fish. So now you can see this is what we call it as lexical ambiguity. A single word could be interpreted in many forms. I hope you understood. Next is the syntactic analysis. So syntactic analysis exists in the presence of two or more possible meanings within a sentence. So a single sentence can be interpreted in more than one form. Okay, so this is also known as structural ambiguity, or you can also, it is also called as grammatical ambiguity. It is called as structural ambiguity or grammatical ambiguity. So if you look into these ambiguities, the chicken is ready to eat, visiting relatives can be boring, I saw the man with the binocular. So if you look into the first one, the chicken is ready to eat. So there could be two different interpretations which we can come up with this sentence. So this is an ambiguous sentence. That is, the chicken is cooked and ready to eat. Could be one. And you might have given some food to the chicken and it is ready to eat. So that could be the second interpretation, right? So whenever you are trying to generate the sentences, right, so you need to understand the context in which they are being used. So if I look into this sentence, so I can go with interpreting two different forms. One is either the chicken is cooked and ready to eat, or it could be chicken where the food is being served to the chicken and it is ready to eat. If you look into the second one, the visiting relatives can be boring. Is that me visiting to relatives is boring, or they visiting to me are boring? So I can interpret two different forms out of this sentence. If you look into the third one, I saw the man with the binocular. So you can see whether the man saw me with the binocular or I saw the man with the binocular. So there are two interpretations. So now you can see how ambiguous the sentences are, the words are. So now I can interpret more. Can you tell me, call me a cab? How many interpretations can I get for this? If I have something like call me a cab, how many interpretations? Is this clear? One sentence, or does it have more than one meaning assigned to it?
More than one meaning.
More than one meaning assigned to it. So you can say that call me a cab. So that could be to get a cab, or the person is trying to say to another person that you call me a cab, right? So I can interpret two different meanings out of these sentences. So this is what we call it as syntactical ambiguities. Then you have referential ambiguities. So in referential ambiguities. So you can see this arises when we refer to something using pronouns. So now you can see the example here. The boy told his father the theft. He was very upset. Now, how do I interpret here? To whom the he is being said here? Is it for the boy? Is it for the is it for the father, or is it for the thief? Right? So I could interpret three different persons for this he. So this is where we call it as referential ambiguity. So if I say some one example, like let's suppose Kiran went to Sunita. He said, I am hungry. Let's suppose a lengthy sentence. Kiran went to Sunita. She said, I am hungry. So now, how can we interpret here? Which one is ambiguous here? Referential, right? I. Now, who is I here? Is it Sunita? Is it Kiran? Or is it any other person? Right? So this is what we call it as referential ambiguity. So they arise when we refer to something with respect to pronouns. Apart from this, there are many other ambiguities which arise while we are performing natural language understanding. So you can think how tough the natural language understanding is. Next one is the natural language generation. So this is the process of producing a meaningful phrases and sentences in the form of natural language. So once if you have the natural language understanding done very clearly, then the natural language generation can be done with around 99.99%. So as I said, this is a process of producing a meaningful phrases and sentences in the form of natural language. So here the machine has understood that we asked them to do right with proper responses which we retrieve from your natural language understanding. So NLGs, you can see natural language under generation deals with producing written or a spoken language from a raw data. So this is a refined data or the raw data which is been sent to the machine. So now you can see the machine or the human understandable language is being generated. So NLG deals with turning this raw data into simple human understandable language, or in other words, producing natural language from a raw input. So this natural language understanding acts as a translator that converts the computerized data into a natural language representation. So NLU mainly involves three important things. One is text planning, the second one is sentence planning, and third one is text realization. So text planning is what to extract relevant information or relevant content from the knowledge base. So that means you are trying to retrieve a plain text from the knowledge base like the humans do. Like I'm going to talk about the language model. So where you will try to understand how the predictions are being done, how the user is, how the system is able to predict the next word. Next, you have sentence planning, that is to choose appropriate words, form meaning phrases, and set sentence tone. So since you are generating, so the sentences which are being generated should be in a grammatical form. Next one is text realization. So this is where you map the sentence plan into a sentence structure. So you process all the sentences in a proper sequence or order and give the output. So now when you are trying to do the generation, it would be completely in the form of grammatical structure. So NLU is naturally harder than natural language generation task. So this is a difference which I have already spoken about. So NLU is process of reading and interpreting language. When it comes to NLG, it is a process of writing or generating a language. NLU, you can see it produces non-linguistic outputs from the natural language inputs. When it comes to NLG, it produces constructing natural language outputs from a non-linguistic inputs. But still, both are very much important. But when you look into the NLU is usually harder than NLG. So these are some of the terminologies which generally come into whenever we are talking about the natural language processing. That is phonology. Second one is morphology. Third one is morphemes and syntax. Phonology, as I already said, it is study of organizing the words sequentially. Morphology, it is study of construction of words from primitive meaning units. Morphemes, it is a primitive unit of meaning in a language. These all are very much important whenever you are dealing with text or speech. Next is syntax. It refers to arranging the words to make a sentence. Now you can see this sentence is grammatically correct. That, or you can see the is uh, the should be always followed by an adjective. So if you look into the grammatical structure, we always say that the should be followed by either by an adjective or a noun. So in this way, the sentence structures are to be generated. Next, you have semantics. So generated sentences, there should be meaningful phrases. Next, you have pragmatics. It deals with using and understanding the sentences in different situations and how the interpretations of the sentences are being affected. Then you have the discourse, where it deals with how immediately preceding sentences can affect the interpretation of the next sentence. So whenever you are trying to generate the sentences, the context in which they are being used is or should also be taken care of. Next, world knowledge is very much important in order to generate the sentences. So this is the steps of natural language processing. First one is the lexical analysis, syntactic analysis, semantic analysis, discourse integration, and the pragmatic analysis. So this have already gave syntax like lexical analysis. When I look into the lexical analysis, there would be the ambiguities which we also look into. So lexical analysis, it involves identifying and analyzing the structure of words. So this is what we call it as the first phase of natural language processing. So it deals with identifying and analyzing the word structures. So we divide what we do here, we divide the whole chunk of text into paragraphs, sentences, and words. So this phase scans the source code as a stream of characters and it converts it into a meaningful lexemes. Those are nothing but the words, or it could be characters. So it divides the whole text. It could be in the form of paragraphs, or it could be in the form of sentences, and it could be form of words. So there are most common lexicons or normalization techniques which are used for this lexical analysis. Like we have stemming, lemmatization, which we'll see them in the further slides. So next step is what we have, the syntactic analysis. So this is the second phase of natural language processing. This is also known as parsing. So it involves analyzing the words in a sentence for a grammar and rearranging them in order to determine how they relate to each other. Like suppose if I have the school goes to boys, so this is the sentence which should be rejected because it is if you look into the structure of the sentence, it is grammatically incorrect. The school goes boys, it should be the boy goes to school. So I should be able to get into the boy goes to school, the probability to be assigned high to the boy goes to school instead of the school goes to boy. So these type of sentences should get rejected. Next, you have the semantic analysis. So now what does it do? It draws the exact meaning or the dictionary meaning from the text. Let's suppose if you have something like the hot ice cream, so this sentence should be always rejected or disagreed, because it's not always, the ice cream is not followed by hot, it is followed by cold. So if you see this colorless blue ideas, generally the sentence should be colorless green ideas instead of blue ideas. Next, you have the discourse integration. So this is our fourth phase of natural language processing. So, in this step, the meaning of any sentence depends upon the meaning of the previous sentence, because this is where you can see the pronouns which you are, proper nouns which you are going to look into. Next one is the pragmatic analysis. So this is the fifth phase. This is the fifth phase of NLP. So pragmatic analysis, it means the study of meaning in a given language. It process of extraction of insights from the text. So it includes the repetition of words, who said to whom, and so on. Okay, so if I say, so it actually goes with the language aspect of the language. So if I say close the door, close the window, so it could be interpreted in two different ways. Either it could be interpreted as an order, or it could be interpreted which has been said in a polite form, right? So close the door, so the tone which is being used, like if it is being written, then it could be considered, or it would be interpreted as a request. But when you go with the speech, the way in which the words are being pronounced, so based on that, it could be considered either request or it could be considered as a order. So these are the steps of NLP, the one which we have seen. So now if I put everything into one single picture, now you can see for a given input sentence, so the input sentence has to go through all these process. One is the lexical analysis, which is the morphological processing. When it goes once they are being divided, either it could be in the paragraph, sentences, or lexemes or words, they get into the syntactic analysis where the lexicons are considered, are looked with respect to the grammar. Then you have semantic analysis. So based on some semantic rules, the words are being generated. Apart from this, you have to look into the contextual information also. This is where the pragmatic analysis comes into. So now you can see how tough the language, as I said, the language is ambiguous, the language has to be generated, so you need to consider all these steps. Okay, so this is all about natural language processing and the steps of NLP. If you look into the applications of natural language processing, so these are some of the most important applications of text mining, or you can say natural language processing for business. They are like sentiment analysis, chatbots, speech recognition, and machine translations. So apart from this, you can see the search autocorrect and autocomplete. So whenever you search something on the Google, after typing like you would after typing like 2 to 3 letters, it shows you the all possible search terms. Or if you search for something with some typographical errors, it corrects them and still finds relevant results for you. So now you can see how the system is able to understand the words and able to predict what could be the next word. So this is actually the building of a language model. You can say that you there is a spelling error, but still it is trying to correct the spelling. Along with this, it is trying to fill the blank. So how this is happening, so that is where the language models comes into. Next, you can see the language translation. So here the machine translation is the procedure of automatically converting the text in one language into the another language while keeping the meaning intact. Now the Google Translator is much better than the previous, but still there are many things which the translator has to do, because till date there are some of the words which it does not translate correctly. Because when you are talking about language translators, then it should keep the meaning intact. Next, you have your social media monitoring. So, more and more people these days have started using this social media, like for posting their thoughts about a particular product, policy, or matter. So, these would contain some useful informations about an individual, like their likes and dislikes. So, analyzing this, the data actually is in the form of unstructured. So, analyzing this unstructured data can help in generating many valuable insights. So, natural language processing comes as a rescue here in the social media monitoring. So, where I can get lot of information from the social media platform. Next are the chatbots. So nowadays you see whenever you try to open any of the applications, suddenly a chatbot comes into, may I help you? So customer services and experience are the most important thing for many companies. So it can help the companies in order to improve their product and also keep the customers satisfied. That could be by interacting with every customer manually and resolving the problems. That could be very tedious task, right? So this is where the chatbots come into the picture. So they help the companies in achieving the goal of this smooth, what we say, customer experience. Then you have the survey analysis. So survey analysis are very important. They are way of evaluating a company performance. So companies conduct many surveys to the customer feedbacks on various products. So this can be very useful in understanding the flaws and help companies to improve their products. So the data which is being generated here would be in the form of text. Next is the targeted advertising. So this is the very much which is you can say it speak like let's suppose if you are trying to if you are trying to look into one genre of uh, what you say on the Instagram. Uh, so you keep on getting the same reels. Like if you are seeing a comedy around 3 to 4 times, then the next reel would be all about the comedy. So how the things get, how the system is able to understand you. And one more thing, when I say targeting advertisement, like let's suppose I was trying to search for some product on the Amazon. Immediately after some time, I have tried to open my Facebook. So you could see there would be the advertisement with respect to what you have seen on the Amazon, or there could be the reels which you have seen on the Instagram, which could be shown on your Facebook. So this is what we call it as targeted advertising. Next one is hiring and recruitment. So the human resource department is an integral part of every company we know. So how they are able to look into each and every resume. So this is where one of the method they use, or which we can use for, is named entity recognition, NERs. So this will help me understand if there is a resume. So now I would because the HRA may get around thousands and thousands of resumes per day. Going through each and every resume would be a tedious task. So they can go with looking into the name of a person, the organization where they have worked earlier, what was the salary they have, and what are the education qualifications. So these are the main important points which they can extract from the given resume. So this is one of the applications of natural language processing. So you all know the voice assistant, the question answering system. So you have a lot of voice assistants. So Siri, Cortana, Alexa, Google, and the list is going on. Then you have your grammar checker. So grammar checker is an application of NLP. So this is one of the mostly widely used applications of natural language processing. So everyone nowadays we are looking into this. Next you have the email filtering. So previously if you look into the mails, we used to have only inbox, spam, and trash. Now you can see there are many folders which are being created in the Gmail, so that the mails which you get, they can be filtered with respect to the content in they are being written, and they are being bifurcated into different folders. So this is where the natural language processing plays a very important role. If you look into the research point of view, apart from this, these are some of the deeper applications of NLP. So they are grouped into 1, 2, and 3. The 3 are the advanced ones, and the second one are the medium ones, and the first one are very important. Without them, we won't be able to go to 2 and 3. Next, these are the states of NLP. So mostly solved problems are spam detection, text categorization, part of speech tagging, named entity recognition, information extraction. But still, there is a research scope where the people are working with. That is nothing but semantic search, question answering, textual information, summarization, discourse, and dialogues. So if you look into this, is very important step where the NLP pipeline. So now there are many steps which are involved in natural language processing, like tokenization, stemming, lemmatization, part of speech tagging, named entity recognition, chunking, and so on. So I'll just go through the pipeline in order to you people to understand, because we understood that the language is ambiguous, and when it is ambiguous, what are the different ambiguities which we find. Now let's look into the pipeline of NLP. So the first pipeline, you can say sentence segmentation, or you can say tokenization. So when I say tokenization here, sentence segmentation is what we are doing at the sentence level, so that's the reason we call it as sentence tokenization. So sentence tokenizer, what does it do? It breaks text paragraph into sentences. Let's suppose if you see this is the whole sentence, so it is being divided with respect to the sentence. Wherever the dot, that is the full stop, is encountered, so they are being considered as three different sentences. So I have one single sentence here. So now when I perform sentence tokenization, so I have hello everyone, welcome to CSE department. You are studying natural language processing. So tokenizing is splitting up the text into minimal meaning units, is what we known as tokenization. So the tokenization can be done at the word level, it can be done at the sentence level, it can be done at the paragraph level also. So if it is a word level, so you can see Joyce doesn't share pizza. So I have 1, 2, 3, 4, 5, 6 tokens for this given sentence. Even when you are performing tokenization, there are many other issues which will come into, because you can see there is an apostrophe here. So how we are going to deal with such type of apostrophe? Should I consider DOESN as one token and apostrophe T as another token? So whenever you are performing tokenization, there would be many issues which may rise. Let's suppose if you have something like, sorry, state of art. So this is a word which means a single form. So whenever you're trying to perform a tokenization, then the state would be one token, off would be considered as another token, and art should be considered as another token. But when you do this thing, then definitely you are going to lose lot of information. So whenever you are performing tokenization, this whole part should be considered as one single token. So this is where you are going to consider the hyphens among this. So tokenization, whenever you are performing tokenization, so you will have issues with respect to the apostrophes, you will have with hyphens, even you have with respect to dots. Like if you say, let's suppose if I have something like ph dot d, if I go with removing the dot here, then it would be considered as ph as one token and d as the another token. No, it has to be considered as one single token. So tokenization is a very important part of the NLP. So you should be looking into these apostrophes, hyphens, dots whenever you are performing tokenization. Okay, so this is one of the example for the word tokenization. You can see the sentence are being tokenized, even the dot is being considered as one of the token here. So you can go with refining them, that the dot should not be considered as one of the tokens. Why the tokenization is important? Because after performing tokenization, you will be getting the most important words to be considered. And one more thing is, whenever you are performing tokenization, always make sure that the text is being converted into the lowercase form, because if I have something like HAPPY in capitals and HAPPY in small letters, then this would be considered as one token and this would be considered as another token. But in reality, both are same. So the tokenization also can be done at the unigram, bigram, and trigram level. So the one which we have seen in the this one word tokenization is the unigram level. So you can go with performing the tokenization of two words, three words, and so on. So now you can see this example. I love natural language. So this is the unigram model where the tokenization is single words. When you look into the bigrams, so you have I love natural. That is nothing but the consecutive words which are being considered. So this would be considered as one token. Love natural would be considered as another token. Natural language would be considered as another token. Next, trigrams, that is three words. So you can see I love language, love natural language. So I would be having two tokens when I consider trigram. When I consider bigrams, I have two tokens as together. When I consider unigram, they would be single tokens. So if you look into this, where you can see this is the unigram, this one is the bigram where the two words are being considered, and this one is the trigram where you can see the three words are being considered. 4 grams, 5 grams based on n value of n you can go with. So now you can see this is 4 grams. So 4 words are being considered. Why I'm taking this unigram, bigram, trigram? Because in the language models, the predictions would be based on these only. Next is stemming. So stemming is process of reducing the word to its word stem by cutting off the beginning or the end. So now you can see in a document, I could have more number of forms of these words. Like you can see affection, affects, affections, affected, affection, and affecting. So I could have one single form instead of considering 1, 2, 3, 4, 5, 6 tokens. I could have one single form of these 6 tokens by removing the ions, the s, the ions, eds, ions, and ing form. So I could have only one form, that is effect. So that is what the stemming does. Next is the lemmatization. So lemmatization is the process of reducing the words into their lemma or to their dictionary form. So you can see here, like you gone, going can go to go. So if you see the stemming and lemmatization, so most of the times it happens that many of us get confused with what actually the stemming and lemmatization are doing. So if you look into the stemming actually removes the affixes like IES, ING forms and IN forms. So you will be remained with the previous characters. But when you look into the lemmatization, it goes to the dictionary form. The studies, the dictionary form of studies is study. Giving, the dictionary form is give. Buying, the dictionary form is buy. So now if I perform stemming, so you can see it will become, the studies will become study. The giving will become give. The buying will become buy. So this is the difference between a stemming and a lemmatization. So you can see this is one of the Python program where you can see we are performing the stemming. So draw, drive, study, give, okay, buy and buy is same, seen and see. So you can see how, and this is done based on the part of speech. So in this way, you can go with using your part of speech and convert these lemmatization. Next one is stop words removal. So these are helpful in English language, but not much helpful in the language processing, because as we know the stop words, they help me how to build the sentences. But when it comes to language processing, so sometimes these stop words would not be of most use. Like for example, in the sentiment analysis, the I generally need the nouns. We generally need the nouns. We need adverbs and we need adjectives, right? So these are very important tag sets which are important. So apart from this, there is no need for me to get all the stop words into my collection. So this is where the stop words are can be removed based on the application in which they are, based on your application. So you can see these are the stop words of the English. So when I go with removing the stop words, so you can see, hello everyone, welcome. So the two is a stop word, so it is been removed. So you have CSE here, department, you. Next is R is a stop word, so that is been removed, studying natural language processing. So this is the sentence which has been generated without stop words. Next one is dependency parsing. So dependency parsing also plays a very important role in the sentence generation because, as I said, to which the I is referring to is very much important. So dependency parsing is used to find how all the words in the sentences are related to each other. Then you have the part of speech tagging. Since the sentences are to be generated in a grammatical structure form, the part of speech tagging plays a very, very important role. So when we talk about part of speech tagging, so everyone knows there are 8 part of speech tags like nouns, pronouns, verbs, adverbs, adjective, conjunction, preposition, intersection. Apart from this, with respect to the plural and singular, we have many other part of speech. So you can see these are the tag sets and the descriptions which we find in different part of speech taggers. So you can see this example, Joy loves pizza. So Joy is noun here, loves is verb and noun is pizza. So you can go with building your own part of speech taggers, or you can use the Stanford part of speech taggers or Porter Stemmer part of speech taggers. So there are many taggers which are available. So now you can see this one of the examples. So you can see each word is being tagged with its part of speech. So how the sentences are generated? The sentences are generated based on the part of speech only. Okay. Now you have the named entity recognition. So the one which I said in the hiring case, like for how the HRA would be using it. So you can see named entity recognition is process of taking a string of text as an input and identifying the relevant nouns. So that could be places, people and organization, right? So in this way, the named entity recognition would be helpful. Now you can see the example here. The Google CEO Sundar Pichai introduced the new Pixel at Minnesota Roy Center event. So where you can find that the Google is an organization, Sundar Pichai is a person, and Minnesota is location and the organization. So in this way, you can go with understanding what are the different entities of a sentence. So if I use the named entities here, so you can see the entities are being tagged. So next, so this is NER. So they actually go with the locations, organization. Generally, you can say they go with the nouns. All nouns in the named entity recognition, we consider nouns. So location, organization, person, facility, geopolitical entities, geosocial, political groups. Next one is the chunking. Chunking plays a very important role. Okay, so like chunking, you can see the part of the text which I want to analyze, then I can go with performing the chunking. Like suppose if there is some comparison going between two products, like let's suppose I say Nokia is better than Samsung. So now you can see this is part of the chunk which is making me identify that there is some comparison is going between two nouns, that is Nokia and Samsung. So this would be very much helpful to the companies in order to understand how the comparison is going between the two different companies. So this is between the company. There could be with respect to the features of the mobile phones, right? It could be about the movies. It could be about the restaurants, right? All your viewpoints. So this is where the chunking plays a very important role. So if you look into the NLP API, so you have IBM Watson API, Chatbot API, speech to text API, sentiment analysis API. So there are different types of APIs which allow the developers in order to integrate human to machine communication and complete several useful tasks such as speech recognition, chatbot building, you can say spelling correction, sentiment analysis, and so on. If you look into the techniques and methods, so you can go with using your machine learning, or we can go with the statistical inference, or you can go with the combination of both the methods. If you look into the major areas of research and development, so these are the major areas of research and development where you can start with the smaller one, that is from the text processing to speech translation. And if you look into the industrial application, then there it may go start with the search engines, advanced text editors, commercial machine translation systems. These are being built, but still there are many loopholes which are being found in these applications. So these are the major areas of research and development when I look into the industrial applications. So, what are the different methods, libraries, which I can use in order to implement the NLP concepts? So, there are widely used NLP libraries. You can see there is NLTK. So, this is most well known and full NLP library. Then you have Spacey. This is fastest NLP framework, where you can see the process of NLP pipeline, which we have seen. It has beautifully built in pipeline for the natural language processing. Then you have the Scikit-learn. Then you have Jinsim. So these are different NLP libraries which help us to go with the natural language processing, deal with the natural language processing. So first one, NLTK. So this is a leading platform for building the Python programs in order to work with the human language data. So it actually provides easy to use interfaces. So there are around 50 corpus and lexical resources which are available in this NLTK package. So you can just download this NLTK with respect to the Python. So NLTK dot download, where you can see it has the number of collection, corpus, models, and if you want to download all, then you can go for all packages. So these are some of the reference books if you are into natural language processing, like you want to start your natural language processing journey, then this is one of the best book, which is Speech and Language Processing, an Introduction to Natural Language Processing, Computational Linguistic and Speech Recognition. This is by Daniel Zurowski and James Martin. Apart from this, there are other books. This book is freely available online, so you can reach to this book by just just typing this book name in your Google search. So you'll find the PDF of this book. Next, you have the Foundations of the Statistical Natural Language Processing. Even this book is very good. And apart from this, if you are deeper into the text analysis part, then computational approaches for the morphology and syntax. Then you have statistical machine translations. You have statistical methods for speech recognition. Then this is one of the most beautiful, I can say, the book for the beginners who want to get into natural language processing with the Python. This book has complete information regarding NLP and each and every step of NLP. It has been designed beautifully. So this is available online in an HTML form as well as in a PDF form. So for the beginners who want to learn about natural language processing, the complete steps which I have given, how they actually work, so they have used Python, and the corpus are also used from this NLTK library. Next, you have taming text. So this is with respect to Java. Though if you are not into Python, then you can use this taming text in order to use the Java language to deal with the natural language processing. Then you have text mining with R. So there is another R, that is data mining tool. So which you can use, our statistical mining tool, which we call them R. So this is text mining with R. So this is another book, Text Analytics with Python, which was written by Dipanjan Sarkar. So these are some of the practical books. So one, two, three, four practical books which I have introduced to you. You can go through these books. Apart from this, these are the other reference books which you can go for your theoretical part. So this is all about the natural language processing. I hope you got a glimpse of what is a natural language processing, how important the natural language processing is, right? I hope this is clear to everyone, natural language
Yes, ma'am.
processing.
Yes, ma'am.
Let me get into language models now, because you will be get introduced to large language models. So before getting into large language models, you should be able to understand the basics of the language models, how actually the language models work. So let's start with the language models. I'll share 1 second. I hope the slides are visible. I hope the slide is visible, right? So
Yes, ma'am.
Yes, ma'am.
So this is a language model. So this is one of the most important topic in natural language processing. You can say this is a building block of our NLP applications, and it is very useful. So, language models are fundamental components of NLP and computational linguistics. So, they are designed in order to understand, generate, and predict human languages. So, before getting into language model, let us try to understand what actually the predictions we are trying to look into. So, let's start with the word prediction. Let us try to predict a word that comes after a given sentence or a given sequence of existing words. Okay, so imagine you have seen some beginning of the sentence like this. So if I say this is the dash, so how would you continue it? What could be the word which can fit into this sentence? This is the. How would you continue it? Yes. What could be the word which can come after the? Yes. That is the whole language model we are going to talk about.
Root,
This is the
root.
root. This is the root. Uh, so that means you are trying to say that the will be followed by a noun. There could be a word. Yes. The would be followed either by an adjective, or it could be followed by a noun. Let's suppose if I have this is the house, right? This sounds good because the is being followed by a noun. Next one is this is the rat. Even this sounds good because it is being followed by a noun. Now, if I say this is the did, does it sound good? No, it does not sound good. So now this is where the predictions are to be done. So the prediction of the next word with respect to the previous words. How the predictions can, like how you are able to predict what could be the next word with respect to the previous word. Let us try to have one more example. Now tell me what is the answer for this? To be or not to?
B.
B. Very good. The pen is mightier than the
Should.
sword. You can't judge a book by its cover.
Quality. Cover.
Its cover. Right? So how you were able to answer these blanks very fast? Right? What could be the reason behind this? You were able to do it. Now I want the system to do the same thing. To be or not to be, if it's been given, the system should be able to predict it is B. If I give the pen is mightier than dash, then it should be able to predict sort. You can't judge the book by dash, then the system has to predict it as its cover. So I want to build such type of a system. So this is what we call it as modeling of a language. So we were able to answer this because you have some intuitions, that is you might have read some books or you might have seen some text, and or it could be your prior knowledge from where you were able to answer the given question instantly, right? So if I say knowledge, then it could be a domain knowledge, it could be a syntactic knowledge, and it could be a lexical knowledge. That means how we are going to fit the words. So the words could be fit, it could be based on domain, it could be based on syntactic knowledge, or it could be based on a lexical knowledge. Let us try to understand with an example. So if I say domain knowledge, so you can see the word red, which is used in two different places, with one red with respect to blood and the other red with respect to hat. So now the red plays a different role in these two words with respect to these two words like blood and hat. So that is what a domain knowledge. Next is the syntactic knowledge, that the word the should be followed by an adjective or a noun. Next is lexical knowledge, that is nothing but baked potatoes or steak. Almost they are similar, so some may call it as baked potatoes or some may call it as steak. So how can we build some similar intuitions for the computer? So we can build by estimating the probabilities of the next word with respect to the given previous word. So now this is what very important, that based on the previous words, you are going to predict the next word. So for doing this, we need some data. So this is where we'll be looking into some of the simple statistical techniques in order to predict the next word with respect to our previous words. So the goal of the language model is to assign the probability values to a sequence of words. So if you look into the when I talk about probability assigning, so why we want to assign a probability to a sentence, that is very important to understand. So let us go with some of the examples that there is a need to assign a probabilities to the words. So this comes up in all sort of applications. So I'll go with first application like machine translation. So in the machine translation, what I am trying to do, I'm trying to distinguish between a good and a bad translation with the help of probabilities, because this will help me out to understand which is the correct translated sentence is. Let's suppose if I have high winds tonight and large wind tonight, as we know that the high wind tonight should have a higher probability than the large wind tonights, because when you look into the grammatical structure of the sentence, the word high should have the higher probability than the word large. The winds tonights are same here, but when you look into the two words high and large, the probability, the value for the high should be more than the value for the large. This is where the probabilities plays a very important role. So the probability of this sentence should be high than this sentence. Then only you will be able to retrieve or generate the correct sentence. So this is one of the example for the machine translation. If you look into the spelling corrections, so now I have shown one of the applications, auto corrections in the Google. So what are the spelling corrections are? So this is the spelling corrections are done based on the candidate corrections. So I'll show with an example. Like you can see, like the person was trying to type a sentence, I like to write this word, it should be word, but he ended up with writing a typographical error. Instead of O, he has typed it as I. So I would be having some candidate correction list or the words. So now if I go looking into each, let's suppose I have three corrected words here and this is the misspelled word. So now I can look into the misspelled words with the corrected words. So the distance between the misspelled and the corrected words is less, then that word would be suggested as a correct word to the user. Let's suppose if I see this one WIRD and this one is WORD. So this is only I to be replaced with 0. Oh, sorry, replaced with O. So the distance between these two words would come to 1. Let's suppose if I consider cost of insert, delete or replace to be 1, then the cost of converting this word into this word is 1 because I have done only one replace here. If you look into this one, WEIRD, so now I need to delete E, I need to replace I with O. So that means I have done two different operations here. That is, one is delete, another one is replace. So the distance would come to 2. Next one is wind, WIND. And if you see WORD, so this is where, let's suppose, I is being replaced with O. Again, I should replace N with R. So again, the distance is 2. So now you can see from these candidate corrected words, the word has less distance from the misspelled word. So now the corrected word, or you can see the probability of this word would be higher than these two words for the given misspelled word. So in this way, the word can be corrected. So now you can see the probability of I like to write this word and the probability of I like to write this word, or a probability of I like this word, then the probability of this should be higher than this should be it will be higher than these two words, because the distance we have seen, the distance between the misspelled and this one was 1. When I considered this, the distance came to be 2. Okay. So now if you look into the another one, so it's instead of minutes, it was typed as minutes. Then the probability of this sentence with the corrected word like minutes should be more than the probability of misspelled words. Now if you see love I cats, so grammatically this is not a structured sentence. So now the probability of I love cats should be higher than the probability of love I cats. Next one is the speech recognition. So speech recognition is completely based on the words they are being pronounced. So now you can see I saw a van. So when it is being pronounced, because the pronunciation of the words in the speech form, they may sound similar. Some of the words may sound similar. So you can see some of the examples here. I saw a van could be generated like eyes or of an, which sound similar. These are the words which sound similar. Now, if you look into the second one, the computers can recognize speech. So you can see how the recognize is being translated as recognize. Now, if you look into the third one, give peace a chance. So instead of peace, it might be translated as peace. If you have ice cream, so it may be translated as ice cream. Next, you can see two birds are flying. So the birds could be spelled as, or it translated as beards. So you can see the probability of such mistranslation should be very, very less to the corrected translation. So this is where the probabilities plays a very important role in order to generate the correct sentences. So now you can see more likely good British food or good Italian food. So generally we say good Italian food, not the British food. Yes. Okay. So the language models, if you look into the other applications of the language models, so we have handwriting recognition, suggestions in messages, summarization, authorship identification, question answering, sentiment analysis, and so on. So this is one of the major important part of language modeling. So now you have your WhatsApp with you, you have your Google like whenever you type something on the Google, so you always find there are three different words which are being given suggestions to the users. Let's suppose you are typing something on your WhatsApp. So you find there are three different suggestions which are being given with respect to the words which you are typing. So how the system is able to understand that the next word should be followed by from, on, or it. So this would be based on the higher probability word which can be generated with respect to these previous words. So this is actually the concept of the concept of language models. So these three words have the higher probability for being the next word for the given words. So you can say internally for each word in its vocabulary, the language model, what does it do? It computes the probability that it will be the next word, but get to see only the top three most probable words. So another example you can see, how do I convert to? So now you can see there could be many suggestions which I can get into with respect to the search which you have made and the higher probabilities assigned to the next words. So there are different types of language models. One is statistical language models and the neural language models. So in the morning, you were being introduced to some of the neural language models. So I will be going through the statistical language model. So I'll make you people understand how the statistical language models. So these are the base for any neural language model. So you need to understand the statistical language models first in order to get into your neural language models. So I'll just go through these statistical language models quickly so that I can show you how language models actually predict the next words. So statistical models form the basis of traditional language models. So these models, they actually rely on the statistical properties of the language in order to predict the next word in a sequence to the given previous words. So they actually include these n-grams, exponential models, and the skip-bam models. So n-grams, so as I said, they are completely depend on the value of n. So if it is 2, so you are going to predict the next word with respect to the previous word. If it is n is equal to 3, then you are going to uh, predict the next word with respect to the previous two words. So n-gram is a sequence of n items from a sample of text, or it could be from a speech. So if you look into the advantages, n-grams are very simple and easy to implement and computationally efficient. They are making them suitable for applications with limited computational resources. However, they have significant limitations. They actually struggle with capturing long range dependencies due to their limited context window. What I mean by this? In the case of n-grams, so like I would be able to predict this word maybe with respect to previous this word, or I could be go with these two words, or I could be go with these two words. Sometimes it do happen, if the length of the n-gram increases, then it would be very difficult for me to get predicted that the word is applications for the given sentence. Let's suppose I consider this whole sentence. So the probability of predicting dependencies with respect to this whole context would be difficult. So that is what the n-gram technique is. This is what the limitation of n-gram technique. Then you have the exponential methods. So exponential methods such as maximum entropy models, they are more flexible and powerful than n-grams models. So they predict the probability of a word based on a wide range of features, including not only the previous words, but also the other contextual information. That is, in what context they are being written. So these models, they assign weights to different features and they combine them using an exponential function in order to estimate the probabilities. So the maximum entropy models, they are also known as logistic regressions in the context of classification. They are used to estimate the probabilities of different outcomes based on set of features like word preferences, part of speech tagging, and you have these syntactic patterns. So their model parameters are learned by maximizing the likelihood of the observed data. If you look into the advantages of this, so maximum models are more flexible than n-gram models because they can incorporate wider range of features, but they are also complex and computationally intensive when it comes to training. Like n-gram models, maximum entropy models still struggle with this long range dependencies because these entropy models, they actually deal with the fixed length of context windows. So based on the context, maybe it would be the window which it is trying to look for. Next, you have your skipgram models. So skipgram models are type of statistical models which are primarily in word embedding techniques. They are actually used in word embedding techniques. So they predict the context words given a target word with a certain window size. Next, you have word to vec. So word to vec, which was developed by Google for generating word embeddings. So it includes two architectures. One is the skipgram. So, and the other one is the CBOW, that is the continuous bag of words. So skipgram model predicts the context words given the target words. When it comes to CBOW, it actually predicts the target word given the context word. So reverse, both the things do in a reverse way. So there are some advantages of this exponential model, but network based training as well as simple and computationally designed. So both models are trained using neural networks, but they are computationally simple and efficient. So these are the neural language models. So you got a detailed glimpse of these neural language models in the morning with respect to the text analytics using generative AI. So where you were being introduced to neural networks. So the key model types are these recurrent neural networks, transformer based models, and the large language models. So I'll not get detail into these recurrent neural networks and LSTMs because you got detailed input for the recurrent neural networks and LSTMs. So I'll move forward to the language models so that so before that I want to go through all these popular language models in NLP. So the first popular model in language models in NLP is the BERT. So that is nothing what we call it as bidirectional encoder representations from transformers. So BERT was developed by Google. So it is a transformer based model that uses bidirectional context in order to understand the meaning of the word in a sentence. So it has improved the relevance of the search result and achieved, you can say, the state of art performance of many NLP techniques. So generally now most of the people are trying to use this. But then you have generative pre-trained transformer 3, that is GPT-3, which was developed by OpenAI. So this is a large language model known for its ability to generate coherent and contextual appropriate text based on prompts. So with 175 billion parameters, it is one of the largest and most popular language models to date. So you can see 175 billion parameters it uses. Next is T5, text to text transfer transformers developed by Google. It treats all NLP tasks as text to text problem, offering versatility across the task. Then you have word to vec, the same thing, the skip pointers and the bag of words. Then you have ELMO, that is embeddings from language models. So these generate context sensitive words embeddings by considering the entire sentence. It uses bidirectional LSTMs and has improved the performance on various NLP tasks by providing more word representations, you can say. So this ELMO actually works very good with respect to when you want to go look into both the sides. Then you have transformer XL. So this is an extension for the transformation model that addresses the fixed length context limited by introducing a segment level, you can say, recurrence mechanism. Okay. Next you have XLNet. Even this was developed by Google. Then you have Robota, that is robustly optimized BERT approach. So you can see this was developed by Facebook AI. is a variant of BERT that uses more extensive training data and optimization in order to achieve better performance. Next, you have Albert. You can see this a light BERT. Then you have turning and NLG. So these are the popular language models in NLP which you can use it in order to build your language model. So the chat GPT you can see, or there could be many other AI tools which are getting into the market where they are trying to analyze the research papers, they are generating the summary out of the research papers. They are like many things can be done by using this large language models. So language models plays a very important role. As in the beginning I said, it is a base or the important foundation for the natural language processing. Let us get into the statistical language modeling, that is the probabilistic language model. So, as I said, language model plays a crucial role in speech recognition and machine translation system. So, let me get into what actually the predictions or how the probabilities are being calculated for the language models. So, the goal of the language model is to compute the probability of a sentence or a given sequence of words. Let's suppose if I give these are the sequence of words W1, W2, W3 and so on to Wn. So we need to compute the probability of this sequence of words. So now the probability of W would be probability of the sequence of words. So this is related to calculating the probability of an upcoming word. So now how can I go with calculating the probability of upcoming word? Let's suppose I consider a five words or a five sequence of word sentence. So now the probability of predicting W5 given the previous word W1, W2, W3 and W4. So the model that computes either of these, either it could be the probability of the whole sentence or the probability of the upcoming word given the previous word. So this is the probability of a whole sentence. The probability of an upcoming word given the previous word is what we call it as language model. Till now I was talking about the probabilities which are being assigned to the words. So how they are being, so let's see. So this is what we call it as language model. uh, we call it as grammar, but language models are, they also call it as LMs. So how do you compute this joint probability? Let's say the probability of the phrase its water is so transparent that, then how can I go with calculating the probability of this word sequences? So this is where I can go look into the chain rule of probability. I hope everyone remembers the chain rule of the probability. Before that, let's recall the definition of condition probability. So how do you do it? The condition probability, probability of A given B is probability of A comma B given probability of B. If I rewrite them, so probability of A comma B is probability of A by A given B by into, sorry, probability of B. If I have more number of sequence, because I am talking with respect to the text, so definitely I'll be having more number of words. So if I look into more number of sequences, and now you can see the probability of A, probability of B given the previous, probability of C given the previous, probability of D given the previous. This is what I'm going to consider the chain rule of probability. So this is the chain rule. So if I get into the words, let's suppose instead of W1, I have taken X1 here. So now the probability of W1 into probability of W2 given W1, the probability of W3 given W1, W2, and so on. So when I put this into the chain rule, the probability, I want to find the probability of it water is so transparent, then how can I write it? The probability of its, probability of water given its, probability of is given its water, probability of so given its water is, probability of transparent given its water is so. So the joint probability, if I look into, so this is what we are trying to look for. That is probability of its water is so transparent. If I want to find, that could be the probability of previous word given the next word. Okay, so if I write down, then the probability would be the count of its water is so transparent that the word to be the next by the count of its water is so transparent that. Let us try to do this example. Let's suppose this is a toy corpus which I have in order to understand what we actually done here. So now you can tell me what is the probability of house given this is the. What would be the probability of house given this is the? I'm trying to predict that the sentence this is the is being followed by house. So what would be the probability of this with respect to the given corpus? How many fragments you can find? This is the, this is the, this is the, this is the, this is the. So how many you have? Four. You have four. This is the. Now check it out. What are being followed here? House is being followed one time. The malt is followed one time. The rat is followed one time. The cat is followed one time. So now I'm trying to find the probability of the house to the given this is the. So that is out of four fragments, only one. So the probability of this would be 1 by 4, right? The
Yes, ma'am.
probability of getting the sentence, this is the house, out of 4, this is the, right? So that is 1 by 4. So this was very easy for us because I had a small corpus. As a human, we are very much intelligent. We were able to identify that this is being followed by a house. What would be the case when I have larger size of data? So this is where you need to understand or you need to simplify the thing. So instead of looking into each and every combinations, so now what we are going to do, we are going to apply a simplified assumption that is called Markov's assumptions. So Markov assumption, simplifying. So now what does Markov assumption says? So now instead of considering all the words in the sentence, why don't you consider the previous one word, two words, three words, four words, five words, or six words? That is based on n-gram. So now we are going to use this n-gram technique in order to look into the probability of predicting the word that with respect to previous one word, or it could be with respect to two words, or it could be with respect to three words, and so on. So now you can see the probability of the given its water is so transparent. If I look into the bigram model, so this is where I would be looking into only one word, that is that. So predicting the to the given that. Now if I look into two words, then you can see transparent that, the given transparent that. So now there is no need for me to look for the whole sentence. I'm going to look into previous either one word, two word, three word, four words, five word, that is with respect to the value of n. So that's the Markov assumption. Just look at the previous or couple of previous word rather than the entire context. More formally, Markov assumption says the probability of set sequence of words is product of probability of wi given wi minus k to wi minus 1. So probability of sequence of words, product of each word, and the conditional probability of words given for given some prefix of the last few words. So in other words, we appreciate we approximate each component in the product. So this is overall predictions which we are going to apply. I'll explain this with an example so that it would be very easy for you people to understand. So let us see how you go with building the Ngram language model. So these are some of the terminologies which comes into whenever we are trying to build an Ngram language model. First one is the N, that is number of words in the training data. They are tokens. Second one is the vocabulary, that is vocabulary size or the number of unique words. So in NLP, these are the two important words which you have to remember. When I say tokens, tokens are nothing but all the words in my corpus. So these are all the words which I consider them as tokens. When I consider types, if you remember in the stemming, right, in the stemming, affection, affecting, affect, all been converted into one single form, that is affect. So now you can see they are different forms of tokens. So now instead of having three, five, six types of tokens, I could have only one token. So that is nothing but type. That is, we call them as equivalence form of the words. Like if I have capital H, sorry, if I have capital HAPPY and small HAPPY, then these two would be considered as two different tokens. When I normalize them, that is convert them into lowercase form, then I would be having only one token. So that can be considered as a type. So this is a difference between a token and a type. Types are nothing but the equivalence form of the words, and tokens are nothing but all the words in our collection. Is that clear? Because many of us get confused with the tokens and the types. Types are nothing but the equivalence classes of the words, and tokens are all the words in the collection. So let's start with small examples. So I'll go with the unigram model first. So this is the simplest case of Markov model, which we call it as unigram model. So when a words are being generated in the unigram model, so you can see that the relation between each word, you will find there is no relation between the words, because these are the words which are being generated, or you can say they are uniquely generated. So they are there, you don't find any dependency on the previous words. So you can see fifth and doesn't have any combination, and off doesn't have off futures, futures the and incorporated, and so on. But when you go look into the bigram model, this is because they are dependent on the previous word. So definitely you may be finding some of the dependencies in the word. So you can see 55 yarn, your 155 yarn, and so on. Outside new car. So you can see there is a relation here, new car parking. So you can say that the new with respect to these two are the parking with respect of parking lot. So with respect to lot, there could be parking, there could be car parking, new car parking, and so on. So in this way, because the unigram model does not depend on the history or any words, the bigram model depends on the history, that is one word. The trigram model depends on two words, and so on. So we can extend this to trigrams, 4 grams, and 5 grams. But as I said, they actually fall less when it comes to long distance dependencies. You can see this example. The computer which I had just put into the machine room on the fifth floor crashed. Now, if I want to predict the word crashed with respect to this sentence, will I be able to? If I consider the previous word floor, the floor will not give me the word crash. If I consider fifth floor, even this will not give me the word crash. If I consider the fifth floor, this will not give me crash. On the fifth floor, nahi dega. Room on the fifth floor, nahi dega. Machine on the room, machine room on the fifth floor will not give me the answer. Where the answer is lying, the answer is lying somewhere here. When I have some like computer, then I can go with predicting the word crashed. So this is what we call it as long distance dependencies. When you consider trigram, 4 gram, 5 grams, you may reach till here, not more than that. Even if you go with increasing bigrams, then it would be very difficult for us to predict the word crashed with respect to the given previous words. So this is one of the limitations of the n-gram model. That is, it does not go with our long distance dependencies. But we can often get away with the n-gram model. So now we have a lot of neural network models which actually deals with this long distance dependencies. So same thing, Marco assumptions, how do we actually represent them? So this is bag of words model with n-grams. So you can see n is equal to 1 word, 2 words, n is equal to 2, 2 words, 3 words. So when I represent them in the probability form, so you can see the unigram model does not require any previous word. So they are all unique words. But when it comes to bigram model, it requires a one word history, that is the previous word. When it comes to trigram model, it requires a two word history. When it comes to n-gram model, so it depends on the n words history. So how do you estimate the n-gram probabilities? So this is where the maximum likelihood estimate, because all the probability, I can't go with considering all the probabilities. Now this is where the probabilities, the one which has the higher probability has to be considered. So this is what we call it as maximum likelihood estimate. I think time is up. I need to cover this. चला गया. Acha, so I have one more lecture. I think till now, I hope you understood what is a language model is, what are the natural language processing is. So I'll get into these things in our next lecture. How you go with calculating the probabilities along with the large language models. I think on the fourth day. Is that clear? The language model is clear to everyone.
Yes, ma'am.
Yes.
So, will you be able to sit for more 15-20 minutes, or should I go in the fourth day session?
No, you
I'll
can
go with the
continue.
practical part of language model. Yes, yes, sir.
Yeah, you can continue.
Ma'am, please continue.
Acha, sure.
We will adjust.
We'll
Okay,
adjust more.
okay,
Thank you.
okay. Okay, then I'll continue with this. Okay, so now n-gram models, they estimate the conditions from the n-gram count. So this is where the maximum likelihood estimates comes into. So maximum likelihood estimate, it is method of estimating the parameters of a statistical model given the observations. So by finding the parameter values, the one which maximize the likelihood is being considered. So let me go with an example first. Let us try to how actually the maximum likelihood estimates are being calculated. So you can see the probability of upcoming word, that is the word to be predicted given the previous word. So probability of wi given wi minus 1. So how can I write the count of the previous word comma next word by the count of wi minus 1. This is what we have done in this. This is the house, right? Given this is the. So now say how many times the word occurred together, and for in order to do this you actually need a data. You need a knowledge, then only you will be able to predict the next word. If you don't have any data, then you won't be able to predict the next word. So how many times the previous words are being occurred? So I'll go with an example. In order to do this, there are some of the things which points which are to be remembered whenever you are dealing with such type of data. So the data, all the sentences in the data set should have the start and end of the sentence, because I need to understand where the sentence is starting and where the sentence is ending. Then only you will be able to predict the next sentence. Next, you will be looking into the count of the frequencies, that how many times the n-grams are being seen. Then you are going to calculate the probability. So these are the major three steps which we'll be looking into. So I'll take small example here. Let's suppose I have a corpus. I am Sam. Sam, I am. I do not like green eggs and ham. So these are the sentence. So I'm placing the start and end. So in order to make sure that this is start of a sentence and this is the end of the sentence, so that I can calculate the probabilities for the I and also for Sam. I can calculate the probability for Sam here, I for ham here. So that's the reason the start and end symbols are very much important here. Now we have our this is the bigram model where I'm considering the one word history. So this is a bigram model. This is bigram model. So where you are considering one word history in order to predict WI. So now you can see the probability of I given start, that is count of how many times I is being followed by I by count of start. So now you can see I is been followed by start is been followed by I one time, start is been followed by I two times. So now it is 2 by how many times the start is been seen, 1, 2 and 3. So the probability of I to be the probability of I to be predicted with respect to start is 0.67. Similarly, next, Sam given start, can you tell me what is the probability of this? That is count of start followed by Sam given count of start. How much probability you are getting there?
1 by 3.
1 by 3, because the start Sam is being seen one time by, there are 3 starts here, so 3, 0.33. Similarly, if am and I, can you tell me am and I? That is count of I to be
2 by
followed by am by count of I, right? How much?
2 by 3.
2 by 2 by
2 by 3.
3. 2 by 3. So it's coming to 0.67. So in this way, I hope you understood how the probabilities are being calculated with respect to the previous word. So now if you look into end of the sentence and Sam, so it's coming to 1 by 2. Probability of Sam given am, so it is 1 by 2. Probability of do given I is 1 by 3. So in this way, we get the probability values for each and every sequence of words when I am using a bigram model. Okay. So let me explain this, how actually into the real-time data, how actually they look like. So let's suppose this is a Berkeley restaurant project sentences. So let's look in, like we are looking into a larger corpus in order to get some realistic counts. So if you look, so if you look, so this is the realistic count. So out of 9,222 sentences, so this is the count matrix which is been built here. So we call them as raw bigram counts. That is the count matrix. That is how the I is being followed by I 5 times. The want is I is been followed by want is been seen 827 times in this 9,222 sentences. Similarly, you can see want followed by I. So it is being seen 2 times only. Okay, so this completely tells me about how many times the words are being followed. Like two given want, two want is not being seen in this 9,222 sentences. That's the reason it is 0. But you can see When you look into this data, there are more number of entries are zeros. That means these are the pairs which are not being seen. So these are the pairs which are not being seen. You have to remember this, that these are the pairs which are not being seen. I'll ask you the question in the next slide. Okay. So unigrams, as I said, unique words. So I is been seen 2,533 times in that 9,000 sentences. So these are my unigrams. So when I build a probability distribution table for this bigram model, so you can see the probability of two given want. You can see the probability of two given want, matlab the count of want to be followed by 2 by count of want, right? This is what you are looking into. So now want 2 का क्या था यहाँ पे? Want 2 is 608. Want 2 is 608 divided by how many times the want is being seen? 927 times. So this is giving me a probability of 0.66. So you can see 2 given want 2 is 0.66. So this is the background probability distribution table which shows the probability of the pairs which are being seen. So now still you can see wherever the zero, that means these are the pairs which are not being seen. So when I go with calculating the probability of this sentence, so you can see from the previous table, so the probability is coming to around 0.000031. Same thing you can see the probability of English given want or in probability of Chinese given want. So what kind of knowledge are being expressed by these diagrams if you look into? So the probability of English given want is less than probability of Chinese given want, because we always talk about Chinese food, more times Chinese food than the English food. That might be the reason the probability of Chinese given want is more in this case. Okay, so that might be because people like more Chinese food than the English food. So this is high because want is a grammatical part and used very frequently. If you look into these probabilities, so you can see in practice we don't keep these probabilities in the form of probabilities. In fact, we keep them in the form of log probabilities. So there are two reasons for this. One is to avoid underflow. The other one is like adding is better than multiplying. So these are the two conditions which we look into whenever we are calculating in the log space. So this is what I was talking about, data sparsity. So you, when we calculated this maximum likelihood estimate with the probabilities between the pairs, most of the times what happened, we have seen there are zero probabilities. That means these are the pairs which are not being seen. When I go with training such type of data, so whenever you go with testing with another data, if the pair is not been seen, then the whole probability will become zero. If the pair like 1, 2 is not been seen, then definitely it will be a zero. So the probability of that whole sentence or the probability of that pair would be zero because the pair is not being seen. So how can we overcome such type of sparsity? So this is where we look into smoothing. Okay, smoothing is a very important technique in order to handle this data sparsity. So these are some of the language modeling toolkits, which are like they are publicly available language model toolkits, which you can go through. And there is one more. This is not Google Ngram release. There are many releases. This is my old slide. So August 2006, you can see here. There is Ngram release. You can see with respect to the Google Books Ngram viewer and so on. I'll practically, like theoretically, I'll try to explain. So you can just think about practically when you are trying to implement in a programming language, what are the things to be considered whenever you are doing this in order to predict the next word. Let's suppose if I have a corpus like this, I saw the boy, the man is working, I walked in the street, then you have the vocabulary. So the vocabulary would consist of all unique terms. So there won't be any repetition of the terms. You can see I is being seen two times in the corpus, but the vocabulary would consist only one time. Okay, saw the boy, man is working, walked in the streets. So you go with building your unigram count table. So unigram count table, where that is how many times the words are being seen in the corpus. So this is my unigram count table where I got the count of all the words. So you can see start and end also being considered here. When you go with you building your bigram table, that is you are going to look into the combination of all the words, like how many times the boy is being followed by boy, I is being followed by I. So you can see there are more number of zeros because these are the pairs which are not being seen. So in such cases, we definitely need the smoothing technique in order to overcome this data sparsity. Okay, so if I want to estimate what would be the probability of this sentence, I saw the man for the given data. So now you can go with splitting this into the bigrams. If I'm using a bigram model, then you compute the probability using your maximum likelihood estimate. How do you do it? So that is nothing but the probability of this whole sentence is probability of I to be predicted with respect to start of a sentence into probability of saw given I, the probability of the given saw, the probability of man given the. Okay, from that you can see the probability of start given I given start is coming to 2 by 3. So that is what you'll get from here, these two tables. Next is probability of saw given I. So this is nothing but the count of start to be followed by I by count of start. So this is what you'll get from your bigram table, and this is what you'll get from your unigram table. So this is 2 by 3. This is 1 by 2, 1 by 1, 1 by 3. So we didn't had any zero here. So the probability, we'll be getting some probability value for this sentence. If it was not let's suppose if this pair is not been seen, then the probability will become 0. The probability of the whole sentence will become 0. So this is one of the example for the authorship identification. Authorship identification, for example, like let's suppose nowadays what happens, there are many frauds which are being done. An article which is been written by some xyz person is being copied and rewritten by some other person, right? So how you are going to identify that there is a similarity between the both the articles, or you can see. So this is where the language models plays a very important role. Let's suppose this is a corpus which I have, and I want to check it out whether the corpus which is being written by the same person, like my training testing data is I am not. So definitely I'll be getting a higher probability for this sentence. So same thing how we have done for this. So you are going to calculate the probability of S of this sentence. That is would be probability of I given I into probability of am I given am given I, and so on, right? So you are going to write. I'm already solved here. I am not. So you can see if I place the start of a sentence in order to record the first word. So you can see 3 by 3, 1 by 4, 2 by 4, and 1 by 2. So it's coming to 0.0625. Okay. So this is what I was talking about, the zeros, that is maximum likelihood unknown words. So let's suppose I have another sentence for which I want to find the probability of this sentence. I saw the girl. My vocabulary, this is my training data. Let's suppose this is, I'm considering this as my training data. Previous data as this one. This is my training data. Now I have trained my model on this data. So my vocabulary consists of I saw the boy, man is working, walked in the street. So this is the vocabulary which I'll get from the data. So this is my training data. So now you can see the word girl is not being seen anywhere in the vocabulary or in the training data. So definitely the probability of this sentence will become 0. When I calculate the probability of this sentence, it will definitely become 0. So how can you deal this unknown words or the unknown pairs? So we follow two assumptions. One is what we call it as closed vocabulary assumption. The other one is what we call it as open vocabulary assumptions. So in the closed vocabulary assumptions, the test set can contain only the words from your vocabulary. That means you have your clear cut instructions that whatever is there in my vocabulary, the training set should also have that vocabulary only. That is what we call it as closed vocabulary assumptions. When you look into the open vocabulary assumptions, this is more very flexible. So the test sentence can contain unknown words. So that is nothing but what we call it as out of vocabulary words or OOV. So they are not part of our vocabulary. So now you hear in this open vocabulary assumptions, you can go on adding the new words. So in open vocabulary assumptions, what we do, we go with adding a pseudo word like UNK, that is unknown. So one of the way to proceed as follows. So what we do, we choose a vocabulary or it could be a fixed vocabulary, convert in the training set any word not in the vocabulary. Okay, whenever you have any word which is not in the vocabulary, those words will be tagged or it will have a tag as UNK. So in test set, convert in the test set any unknown words into UNK. So based on that, you go with estimating the probabilities of UNK like for what you have done for the previous vocabulary words. So now any new word which gets into, you are going to place UNK. Alternatively, there are many other techniques which we actually go with, so that this placing an UNK would be a tedious task. So there are many other evaluation methods or the smoothing techniques which we can go with. There is lot many slides. I think I'll stop here. I'll go in the next session with respect to evaluations and what are the performance measures which are being used for the language models along with different types of smoothing techniques. I hope till now I made myself to cover until here. So remaining are the evaluations and the smoothing techniques which I'll cover in the next class.
Thank you very much, madam.
Yeah, it's almost
Thank you, ma'am.
5:37.
Thank you
Yeah,
very
my
much.
throat is paining now. So I'll go with all these different types of evaluation techniques of language models because you actually need this evaluation techniques and this you should know about the smoothing techniques before understanding the larger part of large language models because these are the basic statistical model techniques. Okay, so I hope you got something out of this talk. Thank you so much.
Thank
Thank you so much, ma'am. It's been
thank
really
you.
informative session, ma'am.
Thank
Thank you, ma'am.
Thank you so much, ma'am.
Thank you so